Hi everyone! In this video, we're going to teach you the method of Descartes' rule of sign. First, let's have a background check. The genius proponent of this method used in mathematics is of course Sir René Descartes, a French mathematician, philosopher, and a scientist. Descartes came up with this ingenious method to make solving real zeros in a polynomial function much easier. Basically, using Descartes' rule of sign before solving the polynomial function and finding real zeros will help us identify the number of negative and positive real zeros. Using this method may not be useful in basic problems, but the longer or the more complex problems become, solving for zeros manually and individually becomes a lot trickier, and Descartes' rule of sign is there to help us eliminate the need of testing numbers that will not be a zero of the equation. So, before moving on to the actual problems, let me give you the basic rule for Descartes' rule of sign. For finding positive zeros, first, you'll have to identify each constant's integer. Second, identify how many times the integer sign switches. Third, the number you get and the second number you'll get when you decrease the original number by 2 are the two possible positive zeros. For finding the number of negative zeros, first, you'll have to change each variable's integer to negative. Second, identify if its sign will change depending on the exponent. Third, identify how many times the integer sign switches. Fourth, the number you get and the second number you'll get when you decrease the original number by 2 are the two possible negative zeros. Now, let's move on to the actual sample. This first sample I'll be showing you will show the basic process of Descartes' rule of sign. So we have here x squared minus 4x plus 4. As we can see, the x squared is positive, 4x is negative, and 4 is positive. The signs change a total of 2 signs. Now, we get the number 2. Then what you have to do is subtract it to 2, which gives us 0. Therefore, there are 2 or 0 positive zeros. Now, we'll be looking for the negative zeros. We must change the sign of the integer of each x by multiplying it to negative. X squared will become positive. Negative x has a negative 4 beside it, so it becomes positive, and 4 remains unchanged. Now you'll get x squared plus 4x plus 4. As we can see, there are no sign changes. Therefore, we get 0 negative zeros. I'll be giving you the chance to answer the next problem set yourself. Try and solve this. 3x squared minus 10x plus 7. You can pause the video if you like. Now, congratulate yourself if you get 2 or 0 positive zeros and 0 negative zeros. Now, up to the third problem set. We have here 2x raised to 4 minus 3x cubed plus 5x squared minus 2x plus 8. The same principles applies for this one. We start by looking for the positive zeros by counting how many times the integer changes. We have 1, 2, 3, and 4 sign changes. The integer changes a total of 4 times. So it is either 4 or 4 decreased by 2, which give us the final answer of 4 or 2 positive zeros. Now, we will be looking for the negative zeros. X will become negative x. First, 2 times negative x raised to the power of 4. Since its exponent is an even number, it will become a positive number. Then 3 times negative x cubed. Since it has an odd exponent, it will still be negative. But since it is beside a negative sign, it will cancel out and become a positive. 5 times negative x squared again has an even exponent and has no negative beside it, which means it is positive. Negative 2 times negative x is positive, and 8 is still a positive. There are no changes, therefore there are 0 negative zeros. Again, I'll be giving you the chance to answer the last problem set yourself. Please pause the video. So we have 3 or 1 positive zeros, and 2 or 0 negative zeros. I hope you learned a lot from this video. Until next time, bye!